In this section, we want to solve some equations that also require that we use some of our trig identities. Here's our first one. I want to solve this equation for theta for all values of theta between 0 and 360. And I have 4 sine theta minus 2 cosecant theta equals 0. So I'm going to start by writing this as 4 sine theta minus 2 times cosecant is 1 over sine equals 0. Now I'll multiply both sides of this equation by sine theta, and I'll have 4 sine squared theta minus 2 is equal to 0 times sine theta is still 0. I'll add 2 to both sides and divide both sides by 4, and I'll have sine squared theta is equal to 2 divided by 4, which is 1/2. Take both the positive and negative square root of both sides, and I'll have sine theta is equal to plus or minus square root of 1 is 1, square root of 2 is that. And now I have to ask myself, okay, what values of theta are there for which sine theta is either plus 1 over square root 2 or minus 1 over square root 2? So I end up with theta is equal to 45 degrees in quadrant 1, in quadrant 2, 135 degrees, in quadrant 3, 225 degrees, and in quadrant 4, 315 degrees. So you see I end up with 4 solutions to this equation, and I had to use a trig identity in the process of solving it. Let's look at our next one. I want to find x if x is between 0 and 2 pi, so I'm looking for radian solutions, and 2 cosine squared x plus sine x minus 1 is equal to 0. Well, let's get this all in terms of the same trig function, so it'll be 2 times 1 minus sine squared x plus sine x minus 1 is equal to 0. I'll multiply this out, and I'll have 2 minus 2 sine squared x plus sine x minus 1 equals 0. Okay, I have a quadratic equation in sine x, and so I want to put it in standard form, so I'm going to have 2 sine squared for my first term. I'll have a linear term or a middle term of sine x, and then I want to add 2 and negative 1, and that will give me positive, well, let's see. Let's write this out. Negative 2 sine squared x plus sine x, positive 2 plus negative 1 is going to be 1 equals 0. Now let's see, let's multiply both sides by negative 1, so I'll have my first term positive. So negative 1 times both sides will give me 2 sine squared x minus sine x minus 1. 0 times negative 1 is still 0. So you can see I have a quadratic equation here in sine x. I'll see if I can factor it. And I end up with 2 sine x here, sine x over here, 1 and 1 for my 2 last terms to multiply and give me 1. 2 sine x times sine x is 2 sine squared. Inside I have 1 sine x and another 2 sine x. I want those to add up to minus 1 sine x, so I'll make that negative and that positive. Now I set this factor equal to 0, and I end up with sine x is equal to negative 1/2. I set this factor equal to 0, and I end up with sine x is equal to 1. Now, sine x equal to negative 1/2, I have to find all values of x in radians whose sign is negative 1/2 that lie between 0 and 2 pi. I'll let you do that. Over here, sine x is equal to 1, so I want all values of x between 0 and 2 pi whose sign is 1. X is going to come out to be pi over 2. I'll leave that last step for you. Once we get it down to this point, it's pretty simple from there on. Let's look at our next equation. I want to find theta if theta is between 0 and 360 degrees and sine theta plus cosine theta is equal to 1. So I'm going to have to square both sides of this equation so I can get some squares in here to work with. What I want to do, though, is separate sine theta and cosine theta. So I'm going to write this as sine theta is equal to 1 minus cosine theta. Now I'll square both sides, and it's okay to do that when you solve an equation. You just have to be sure that you check all your solutions back in the original equation before you squared both sides to make sure that you get rid of any extraneous solutions. So here I have sine squared theta is equal to 1 minus 2 cosine theta, there's our middle term again, plus cosine squared theta. Okay, now let's see. Let me put everything here is in terms of cosine on the right side. I'm going to write the left side as 1 minus cosine squared theta equal 1 minus 2 cosine theta plus cosine squared theta. Now let's move everything over to the right side. I'll add negative 1 to both sides, so I'll end up with 0 right here. I'll add cosine squared to both sides, so I end up with negative 2 cosine theta plus 2 cosine squared theta. Now from here, what I'll do is factor out a 2 cosine squared. So 2 cosine squared theta, whoops, I'm just going to take out a 2 cosine theta from each term. So 2 cosine theta times what's left on this term is negative 1, and what's left in this term is cosine theta. When I set this factor equal to 0, I get cosine theta equals 0. When I set this factor equal to 0, I get cosine theta is equal to 1. Now I won't go any farther than that with this problem. Each of these will lead to some solutions. Those solutions I'll take and check back in my original equation to make sure none of them are extraneous. So the point of this problem is that sometimes you need to square both sides of the equation so you can introduce some squares of sines and cosines and be able to use your Pythagorean identity or other identities. When you do that in this section, I would separate the trig functions on both sides of on either side of the equation before you square both sides and make your work a little bit easier. After we do the next section of the text, you'll see that that's not really necessary. But in this section, you should separate your trig functions first.